Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your FiberL4 optical power meter for proper operation using a WaveSource single-mode light source. Patch cables and test equipment should always be checked prior to testing to ensure accurate and reliable test results. In this procedure, we will be using a FiberL4 optical power meter and a single mode port and a WaveSource light source. You'll notice that there are two patch cables and one mating sleeve used in this procedure. This reference cable will be used to connect the WaveSource into the link under test and also zero out the equipment together. This patch cable will be used to connect the FiberL into the link under test, and the mating sleeve will be used to connect these two cables together for the purpose of checking them to make sure they're working fine. Now, one thing to make sure of when choosing test cables is that the connector types match the testers and the patch panel that you're going to be testing. Now, they might not be the same, right? So the one end of the patch cable needs to be able to connect into the testers, and the other end of the patch cable needs to connect into the link under test. Okay, remember this could be SC, LC, SC to ST. It doesn't have to match. For this purpose, we're just going to assume that the patch panels are SC. Okay, first step is to power on both testers. So you press the power button on the FiberL and the power button on the WaveSource. And on the WaveSource, you'll notice that the multi-mode port is lit by default, so we need to switch to the single mode port by pressing the port button. You'll notice that the indicator LED here is red. You may not be able to see it real well, but it's red, and that means that we're outputting 1310 nanometers at this point. On the FiberL, it boots up to an operating mode screen with simple meter and certification meter as options. For this procedure, we're just going to use simple meter. So since it's already highlighted, we press F2 to select. On the screen, we'll see the word under. Okay, what under means is that there's no light entering the photodetector. Okay, you'll notice that there's a dust cap on the photodetector. In fact, you'll notice that FiberL power meters will have two ports. You're actually looking for the port that says detector here. Okay, so because there's a dust cap on the detector port, it says under. When we remove the dust cap, you'll notice that we see a power reading. What's happening now is that the power meter is measuring ambient room light. So that's the only light that's coming in here is light from the ceiling. Okay, so this is normal, so don't worry about that. Okay, you'll notice that the wavelength is set to 850 nanometers. Okay, since we're going to be checking single mode, we need to switch to the single mode wavelength. So the light source is set to 1310 nanometers, so we also need to switch the wavelength on the FiberL. We do this by pressing F3. Okay. Now we connect in the reference cable into the testers. So on one end, we connect into the single mode port on the WaveSource and the detector port on the FiberL. Okay, what we should see is a reading that's around minus 10 dBm. Okay, it could be a little higher or a little lower, as it is in this case, but what we want to make sure is that we're not exceeding minus 11 dBm. Otherwise, this might indicate something else wrong with the cable. But in this case, our reading of minus 10.62 is okay. It's also a good idea to check 1550 nanometers. So we would have to switch both units to 1550 nanometers to check that wavelength. But what I'd like to do here is demonstrate a nice feature of the FiberL and the WaveSource when used together, and that's called auto mode. Auto mode allows the wavelengths to switch automatically. So simply done on the FiberL by pressing the auto button. You'll see it says auto on. The wavelength indicator will now say 1310 auto, and it will be switching back and forth between those two words, basically. What this means is that the FiberL is receiving light, but it's not receiving an auto testing signal. It's just scanning incoming signals for auto, which it's not getting at this point. So we need to set the WaveSource into auto mode as well. This is done by pressing and holding the auto button watching the indicator LED, and the second it starts flashing, we remove our finger. We'll watch it for a few seconds, and it should begin switching between red and green, and we should also see a reading on the screen here. Okay, we'll see that 1310 has a reading of minus 10.6, 1550 is minus 10.37. Okay, so these are both acceptable power levels. We're not below minus 11. We're still around minus 10. So, for the purpose of checking this second cable, we want to zero out temporarily this reference cable. So we do this by pressing the 0 button. And by doing so, we're zeroing out both wavelengths simultaneously. Press yes to confirm, and now we see that we have a reading on the screen. Okay. Eventually, it will show both wavelengths on the screen. Okay, notice we have readings around 0 dB. Okay, this is acceptable. This means that we have actually zeroed out our equipment. This patch cable is okay to use, and both sets of equipment are reading at their calibration levels. Now, to check this second cable, we simply remove the patch cable from the detector port, and don't be alarmed, it's going to read ambient room light again. In fact, it's only going to show one wavelength because it's not getting an auto testing signal. Then we connect the patch cables together using the mating sleeve. And finally, we plug the other end of the test cable into the detector port. And what we should see is the meter will, again, sync up with both wavelengths, and we'll see a reading on the screen here. In this case, we're reading around 0.2 of a dB of loss. Okay, that loss is occurring in this test cable and the mating sleeve. What we want to look for is a reading of around -5 or -0.5 or less. In this case, we're okay. Okay, the reason this is important is because this reference cable was not zeroed out. So the loss in this cable is going to add in to the reading. Okay, but what we've seen here now is that this cable is okay. Okay, both of these cables are okay to use, so we can go on with our test.
If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL Technical Support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.